I needed to go over a couple problems from the homework. Now, about homework, I give you lots of problems each time, right? So you do your best to finish the half of that, okay? So don't look at the answer key. You do all the problems and before the class, and then check the answers. If some you cannot do, okay? You're not able to do. But some problems you are able to do it, but it did not get the same answer. Then you redo the problems, maybe just by mistakes, simple mistakes. So if you still cannot figure out the right answer, ask your parents to send me the list of the problems ahead of time, not just last minute. So I don't check the emails and the WeChat messages. Okay. So what we're going to do today? So I'm going to go over a few problems from the homework. The first one is the following. It's from coordinate geometry. So this is a point lines on the line whose equation is x minus 2y equals -2. Now, what is the value? Okay, so it lies on the line means the coordinates satisfy the equation. So otherwise it's not the point on the line, right? The so-called equation for the line is about the relationship between the x coordinate and y coordinate of the point on the line. So now k -3 is as the coordinates of the point on the line. That means when x is a k, y is -3, you should have this. Okay, so now k plus 6 equals -2, k equals -8. Then simple, right? If you understand the problem. All right, so the next one is a geometry problem. Okay, let's look at this picture. It says that the two bedrooms have the same dimensions, not same area. Same dimensions. Take a look at that, okay? And you have to find the total area of the cottage in square feet. Okay, so you have to add them together one by one. Now, what is the area of the bedroom? The area of the bedroom, you have the length and the width already, right? So when the area of the bedroom, one single bedroom is going to be 20 times 15, right? 20 times 15. So because they have the same dimension, one bedroom given the width, other bedroom given the length. Right, so now you have to find out the area of the remaining part. The area of the remaining part, let's say this part, right? The area of this part, right, is going to be the length times the width. And how do you figure out the length? The length, look at that. The length is, the total will be 55, but you have to minus the length of the bedroom. So 55 minus 20, okay? Times, otherwise 45 minus 15, right? Because 45 is from here to here, bottom, but including the width of the bedroom. So the width of the bedroom is going to be 15. So that's the reason. So you have here 35 times 35, right? Yeah, 35 times and times 30. Okay. So that is the area of the remaining part. So now the total area is going to be 20 times 15 plus 20 times 15. This is the area of another bedroom. And plus 35 times 30. And then you multiply, add them together, you will get the total area, okay? So, okay, let's finish this computation, okay? So 20 times 15 is going to be 300, and then 335 times, 35 times 30 is going to be 1,050. So add them together, that'll be 1,650. Okay, and don't forget to put square feet there. Okay. Okay, that's the total area of the whole cottage. Okay. Yes. All right, so the next problem is a little bit confusing. So what is the minimal number of the square tiles needed to cover a rectangle whose width is 50% greater than its width? Now, here's the point. Square, tile is a square, okay? When we're talking about tile, it means it's a square. This is a tile. Every tile is a square tile, okay? It is square tile. It's clearly stated that it's a square tile, okay? So when a square tile, okay, then so the dimension of the rectangle is not given at all. Dimension of the rectangle is not given at all. But what we know is the length is going to be width 1.5 width, okay, right? Because 50% more greater than its width. So the length ratio, yeah, I put it this way. The ratio length to width is going to be actually 3/2. Okay. So the smallest possible rectangle, the rectangle is smaller than you have less tiles you need, right? So smallest possible rectangle for you is actually there should be 2 tiles on the one side, and 3 tiles on the horizontal side. Okay, so this is a possible, yeah, this is probably the smallest. You cannot have a 1 tile on one side and 1.5, right? The tile is not going to be cut. We have to use a complete square tiles to cover the whole area. So this is the smallest possible rectangle you're going to get. Okay, this side it should be 2 tiles. Here's the 3 tiles. Okay, you can have 4 tiles and 6 tiles. You can have, right? You can have, yeah, doesn't matter. And just multiply. Can you have 3 tiles on one side? No, you cannot have you can have a 4 tiles and 6 tiles on one side. Okay, then other side there should be 9 tiles. But this is the smallest rectangle you are going to get. So we answer the question: what is the minimum number of square tiles needed to exactly cover a rectangle? I think this question is stated. It's not stated in the best way. It's kind of misleading. The rectangle is already fixed. Now the rectangle is not fixed. We should ask, what is the smallest rectangle you can have, which is completely covered by a square tiles. Okay, so then you determine the smallest possible rectangle, okay, which is covered by square tiles. Okay, then you probably can quickly figure out what is that. Okay, so now total here is the total number, right? The number of tiles in this case is going to be 2 times 3, which is 6. So the answer is 6. So if we change the way to state the question, maybe you can quickly figure it out. Okay, so what is the smallest possible rectangle which is covered by square tiles completely, exactly, right? Okay, then this should be the smallest one you can have. Okay, so those are the those are the problems from the homework. Some students did almost all the problems. Some students only maybe did half. Even some students only did a few of them. Right? But if you want to make a progress, you should find the time and complete as many as possible. Okay. I think Felicia is doing a good job. Great. Okay. All right. All right, so we're going to, today we're going to focus on some problems on counting and the probability problems. So I begin with the counting problems, okay? So the first one is we're going to study is about how to count the numbers of factors, okay? So here's a question, how do we count the number of factors? So suppose you have, a number is written, how many factors does this number, which is going to be 2 cube 3 square have? Okay. So I already gave you the number of factorization of the number. Okay. Now you can multiply 8 times 9. It's 72. Okay, this is 72. Now, so a factor means this is number, n is divisible by that number. Okay, then it's a factor. Okay, 2 is a factor, 3 is a factor, 6 is a factor, and 12 is a factor. So a factor must be in the form in the form such like 2 to the p, 3 to the q. And here p is going to be 0, 1, 2, and 3, and the q is going to be 0, 1, and 2. Okay, so those are the possible values for p you can choose. So a factor corresponds to a pair of numbers. So in order to count the factors, you just need to count the number of those pairs of numbers. Okay, yeah, that's right. There are how many choices for p? 4. How many choices for q is 3. So 4 choices, 3 choices, total is 12. Okay, so n equals 72 has 12 factors. Okay, so this is how do we do that. And my next question is, okay. Okay, let's do that. How many factors does 1,575 have? Okay, so first thing we have to do is to factor this number. Okay, when you look at this number, you find out it is divided by 5. So 1,575 divided by 5. Okay, I think even you can divide by 25. The reason is 1,500 plus 75. So 1,500 divided by 25. 75 divided by 25. So you can quickly, do the factoring if you divide by 25. Then will be 63 times 25. Okay, then 63. No, we know that, everyone knows that, right? And 7 times 9. Okay, So it's going to be 7 times 3 squared times 5 squared. Okay, this is called the prime factorization. Yeah, right? It's called prime factorization. So a factor of this number must be in the form 7p, 3q, and 5 to the power r. Okay? Now, this is a one-to-one corresponds to the truth of these numbers, and where p can be 0, 1, q be 0, 1, and 2, and r could be 0, 1, and 2. Okay? So there are two choices for p, and the 3 choices for q, and 3 choices for r. So total, how many triples? Okay, so triples, so there are 2 times 3 times 3, okay? 18, okay? Triples of such numbers, okay? So we can say that that's how many factors you're going to get. Okay, so the key point is to factor the number. Okay. Yeah. So here's the next question. Do one more problem. How many factors does this number, okay, does this 3 factorial, 4 factorial, and 5 factorial have? Okay. This is a product of the 3 numbers, bigger numbers. Okay. All right, so you needed to find the prime factorization of this number, right? And so the number is going to be 3 factorial is 1, 2 times 3, and 4 factorial is 2 times 3 times 4, and 5 factorial is 2 times 3 times 4 times 5. So clearly, you know, how many 2's there, right? You have 1, 2, and 3 2's, and also have 3 2's from the last number, right? So 1 plus 3 plus 3 is 7. And here 3 times 3 is 3 cubed. And then I think a 5. Well, okay, so this is a number. You know, you don't need to multiply them out. It's a prime factorization. And then, clearly a factor maybe is in the form, in this form, as one-to-one corresponds to the strips, and where P is from 0, 1 all the way to 7, Q is from 0, 1 all the way to 3, and I is from 0 to 1. Okay, so you multiply them out, and the total, this number has 8 times 4 and times 2, it's 64 factors. Okay, so we are now familiar with this type of numbers. Okay. All right, so now I'm going to talk about probability problems. Okay. My first problem I want to discuss is if positive two-digit number is chosen at random. Okay? What is the probability that its digits differ by, let's say, by 2? So you only have 2 digits here, right? So there is a difference. Differ by 2, for example. But by definition, a probability is a ratio. The numerator is the number of all desired outcomes. That means you want to have 2-digit numbers. The digits, its digits differ by 2. The denominator is the number of all possible outcomes when you pick up. So you just need to count how many 2-digit numbers there. Okay? How many 2-digit numbers there? 90, because from 10 to 99, there are 90 digits. So we don't need to worry about just 90, okay? Everybody knows that. So I just want to know, I just want to count those 2-digit numbers, okay? Their digits differ by 2. How do you do that? Okay? So you begin with, you know, the number, begin with 1, right? The next one should be 3, right? 1, 3, 1, 4, no, 2, 4, okay? 3, 5, right? And 4, 6, and then 5, 7, right? And then 6, 8, 7, 9. So that's the first set of 2-digit numbers. But it's possible the first digit is larger than second digit, okay? So it begin with 2, 0, okay? And then 3, 1, right? And the 2, 0, 3, 1, and the 4, 2, and so on. And the last one will be it's 9, then 7, okay? So how many of that? The first row, you have a 7. Second row, you have 8. All right, 8. From 2 to 9, 8. So total is 15 over 90, then you simplify it, right? 15 over 90 divided by 3, you have a 5, right? And actually, it's divisible. First of all, you divide by 3, and then 30, and then 1 over 6, right? Continue simplified, and because 30 is 5 times 6, so 1 over 6. Okay, this is the answer. Got it? Yeah, don't forget all the possible case patterns when you count them, okay? Don't forget all the possible patterns. Now, the problem can be many different ways. For example, I still the same question. If a positive 2-digit number is chosen at random, what is the probability that the sum of digits is going to be 14? Or this will be a little bit easier than the previous one. The sum of its digits 14. Or I just say divisible by 3, for example. Okay, let's do this way. Okay. So again, right? So the probability here, the denominator is still 90. right? So as a sum is divisible, the sum is divisible by 3 means we only consider those 2-digit numbers which are divisible by 3. Okay, in other words. Okay, so A plus B, this is a 2-digit number, AB. A plus B is 3. A plus B could be 6. A plus B could be 9. Right? A plus B could be 12. And it's a lot. Okay, in each case, you have to count how many of these 2 digits. Okay, so this will be 15. A plus B is going to be 18. I think 18 is the maximum one because the next one will be divided 21. You never get 21. Okay, the sum of digits never get 21. So you have to figure out how many of them in each case. Okay, how many of them in each case. And then, yeah, so look at, right? So in this case, the second digit, we're talking about AB, right? It's 2-digit number. The second digit could be 0, and then the first digit is completely determined by second digit, right? Then the 1 and the 2. The second digit cannot be 3 because otherwise the first digit will be 0. Okay? And here it's going to be 0 all the way to 5, right? Because when it's larger than 5, then, right? Anyway, the second digit cannot be 6, otherwise A is going to be 0. And then here's from 0 all the way to 8, and here's from 0 all the way to 9 because the maximum is 9. And here, no, cannot be 0 because it's, be careful, okay? I did it too fast. Okay, let me erase this. All right. So think about that. When B is 0, A is 9, that's okay, no problem so far. Okay? And when B increases, A decreases. But here, I cannot begin with 0. I cannot begin with 0 because otherwise A will be 12. That's not a digit. A can be, so I have to begin with a 3. Okay? When the 3 is 9. Okay? Then B could be all the way to 9. Okay? Then A is going to be 3. Okay? When B is 3, A is 9. Okay? And here, when B cannot be smaller than, what is the largest power? I think B here is going to be 6. Okay? B cannot be smaller than 6. Okay? Then A is going to be 9. So 6 all the way to 9. Okay? And here, B is going to be 9. In that case, A is 9. Okay? So you count all of them. Okay? Let's add them together. So this one, it'll be first with 3 plus 6 plus 9. From 3 to 9 is a 7. From 6 to 9, 6, 7, 8, 9 is a 4. And the 1. You see? So you have this many 2-digit numbers divided by 3. Okay, add them together. Okay, so the sum is going to be, let's figure it out. Okay, so 3 plus 6 plus 9 plus 7 plus, so it's going to be 30, which is going to be, 1 over 3. Got it? So 1 over 3, 1 over 3 of 2-digit numbers are divisible by 3 actually. Okay, so this is how do we count them? You have to classify them into different category, and then you count the numbers in each category. Okay. All right, so my next question is, okay, a bag contains 6 red marbles and 5 blue marbles. Okay, if 2 marbles are selected, oh, I don't want to misuse select. Okay, 2 marbles are drawn at random. Okay, so what without replacement, okay, I'm going to skip that word. Without experiment, okay, withdrawn. Okay, so what is the probability that 2 marbles have different colors? Okay, I'll let you try this. Okay. Yeah. Now, if you was the replacement, then you can draw one, put it back, and draw another one, put it back, and what is the probability you get 2 have a different colors, which will be different problems. Okay, maybe more difficult. So let's assume you have 6 red marbles and 5 blue marbles. Okay, in a bag, and then you're going to take 2 marbles. Okay, and there should be a different color. So one is red, other one is blue. What is the probability? Joshua, work on this problem. Kevin, Alan, you have different answers. Now, when you withdraw 2 marbles, right, when we're talking about red and blue, right, we don't count the order. Got it. Okay, we just a pair of 2 marbles. You can withdraw a pair of marbles at the same time, right? We don't count that order. Okay, if you don't count them order, the number of all possible counts, okay? Yeah, how many pairs of marbles, right? Consider a pair of marbles. The number of, how many pairs of marbles? You have 11 marbles. You withdraw 2, right? So 11 factorial, 2 factorial, and 9 factorial. That's the total number of pairs of marbles. Okay, because we don't care which one's first, right? Yeah. The number of pairs of marbles is going to be 11 factorial divided by 2 factorial and 9 factorial, because we don't count the order when we say pairs of numbers. Okay, but we do want to make sure one is red, other one is blue. Okay, how to get red? Right, you have 5 choices for the red. And you have you have 6 choices for red and 5 choices for blue. Okay. Okay, so 6 times 5. Right? Because you can put in this way, right? 5, you can always put the red on the left, right, blue on the right now. Okay? How many choices for the red one? Right? 6 choices. How many choices for the blue one? 5 choices. And then how many combinations, right? That would be 6 times 5. Okay? So let's simplify it. So 6 times 5. And here 11 will be 10 times 11 divided by 9 factorial divided by 2. Okay, so that, 10 divided by 2 is 5. So it's 11, 6 over 11. 6 over 11, Kevin. Good. Okay, 6 over 11. Okay. Excuse me. I got. All right, so our next problem is about 3-digit number. A 3-digit number for which each digit is each digit is 2, 3, and let me check, okay? Okay. Was repetition allowed? This is going to be chosen at the random. Okay. So what the question is, what is the probability that the sum of the 3 digits is going to be 10? Right? All right, so you're going to have a, like for example, 2, 2, 2, maybe 3, 3, 3, and 2, 3, 5, and so on. Okay, those are the 3 digits, 3-digit numbers you are considered. Okay, they only consist of this one of the 3 digits. All right, so among them, okay, among them, how many of them, right, will be the sum of digits are going to be 10. So how do you figure it out? Okay. So you're going to write down a 3-digit number, and then you're only using one of these 3 digits, right? So for the first one, you have how many choices? 3 choices, right? And for the second one, you have 3 choices, 3 choices. For the third one, you also have 3 choices. That's all the possible outcomes. Okay? Because for the first number, right? So question is, how do you count the numerator? Okay, how to find the numerator for this problem? Now the design outcomes. Okay, some of you already got 2/9. Okay, the design outcomes. Okay, we're going to have 2 plus 3 plus 5, which is going to be 10, right? Can you any other possible combinations? No, right? 2, 2, 2, 2 is not 2, 3, 3, 5, right? So this is only possible, the 3 digits must all show up, okay? The 3 digits must all show up. Otherwise, you're not going to get the sum equal to 10, okay? Right? 3, 3, 3, 3, 3, 3 is only 9, okay? And 5, 5 make 10, but it's not going, you know, another digit must be non-zero. So you only have 3-digit numbers consist of the 3 digits, okay? But how many permutations there? 3 factorial many permutation, okay? So the answer will be 2/9, okay, after you simplify it. Okay. Right. So now I'm going to change the problem a little bit. 3-digit number. Okay. Let me copy this, for which I change the number. The question is still the same question. For each digit is 1, 3, and 6 with repetition. Okay. Hold on. Yeah, I'm going to change it to let me change it 6 to 5. Okay. Yeah. Chosen at random. So what is the probability that the sum of the 3 digits is going to be 9? Okay. No, it's not against. It's a different problem. Slightly different problem. Okay. This is 10, right? So here, First of all, the denominator still, right, is 3 times 3 times 3. Okay. The numerator, look, the numerator could be 1 plus 3 plus 5, which is 9, right? But there's also possible 3 plus 3 plus 3 is going to be 9. Got it? Right? Any other possible case? No? Right? So if you use 3 different digits, you have 3 factorial many different 3 digits. 3-digit integers you can create. Now also 3 is one of the possibility, right? So that's why it's going to be 7 and 27. You're right. Yeah, because there is a 3 there. Right. All right, so our next problem will be 2 standard fair 6-sided dice are rolled. If the sum of the numbers is greater than equal to let me check this problem. Okay, so here's the question. 2 standard dice are rolled. Okay, so here's the condition. If the sum of the numbers, we assume we only consider those. If sum of the numbers rolled is greater than or equal to, let's say 8. Okay? What is the probability that the sum is odd? Okay. So you get 2 numbers. And you see, if the sum of the numbers is rolled is greater than or equal to 8. Okay. So you only consider those. Then what is the probability, the chance to get an odd? The sum is odd. Okay. So you have 2 numbers. Okay. You can count the order, right? The A and the B, you count those 2 numbers, right? So A plus B is greater than equal to 8. So you can say A plus B equals 8, A plus B equals 9, A plus B equals 10, A plus B equals 11, A plus B equals 12. Now you cannot just look at, right, that's my hint, okay? The largest possible value you can get is 12. So the question is, what is the probability you will get the sum? Can you do this problem? You think it's 1/3, Kevin says. Any different answers? Yeah, you two standardized road, so you record two numbers in the order. Okay, let's assume that, right? So the first one, the smallest number you can have, let's just look at the B, okay? B can begin with 2, right? Then A is a 6, then B is 3, 4, 5, 6, right? And then that's it. The largest possible value for B is 6. Then A is going to be 2 when B is 6. Okay? So this is how many possible outcomes here? It's already have 5. In this case, B is going to be must be begin with 3 and 4, right? And 6. 6 is largest value you can choose for B. Okay? B cannot be less than 2. B cannot be 2. If 2, A should be 7. Okay? And here, B is begin with 4, right? A 5 and a 6. Okay? When B is 6, A is going to be 4. Okay? Here, B is going to be, and here B is 6. Okay? How many totals of probability, right? The number of all possible outcomes will be, 5 here, 4 here, 3 here, 2 here, and 1 here. So that is going to be 15, right? Yeah, 15. Okay. And then you just look at those, giving you the sum, odd sum. Okay. You have a 2 here. Okay. So that's going to be 6. Right? I don't know how do you get a 1/3. Right? Odd sum, 9 and 11. So you have a 2, 4 plus 2, 6. 6, 2 times 3, and 5 times 3. So that's my solution. Okay? Got it? Yeah, we only consider those, the sum is greater than or equal to 8. The total is at 15 outcomes there. 15 outcomes. Okay? And when you lose, right, you record two numbers. Okay? Then among them, only them gives the other sum. So just takes the ratio. Then that will be 2/5. Okay. All right, so my about the coin flips. Okay, so let me write down the question. A coin is flipped 5 times. what is the probability that, how can I say, what is the probability that so flip it 5 times, what is the probability that exactly three of them landed with hit, okay? Exactly 3 hits. Okay. So I just want to get 3 hits. So you have 5 points, right? And H, the rest of the T. Okay. So can you do this problem? All right. Any different answer? Grant says 1/4. Whoa. Somebody get 5 of 16. So you think 5 of 16 is correct? All right, first of all, let's look at, okay? You have 5 steps here, one by one, right? Each step, there's 2 options. So 2 times 2 times 2 times 2 times 2. That should be the denominator, okay? So the question is, how do you count those was exactly 5 hits? That's 3 hits. Okay? Now you can list all possible design outcomes, but I would like to study this problem in a slightly different way. So you consider the first coin, let's call the C1, C2, C3, C4, C5. You have 5 people there, okay? C4 is always go stand at the 4th place. C5, those are the names of those 5 people, okay? C5 is always go to the last place. All right, in order to, the one pattern is corresponds to, you get C, for example, Yeah, like in this case, C2, C3, C4, okay? So if C2, C3, C4 are selected, then you have this pattern, THHT. If C1, C2, C3 are selected, you will be HHHTT, okay? So the number of those desired outcomes is equivalent to, yeah, the number of outcomes is going to be the number of groups of 3 members selected from a group of 5 members. Okay, so this become the so-called committing problems. Okay, so if you think there is a correspondence here, if these 3 selected, we have 5 members that called C1, C2, C3, C5. If the 3 of them selected, they will be given H and stay in a row. Okay, and then you see the pattern like that, H, T, 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 H. So this will be 5 factorial, 3 factorial, or 2 factorial. Okay, this is the formula we use to count the number of groups of 3 members select from the group of 5 members. Okay, so be 5 factorial over 3 factorial times 2 factorial. Let's simplify it. 5 factorial over 3 factorial is 4 times 5 divided by 2. Okay, and then here is be 2 times 2 times 2 times 2 times 2. So I think 1, 2 is cancelled out, and this will be 5, and this will be 16. Yeah. Okay, so 5 over 16 is correct answer. Great, good job. Okay, congratulations to those who got the right answers. So when you study probability problems, you translate the problem to another equivalent problem, then use a formula, you can quickly figure it out, okay? Otherwise, if you list all of them, sometimes we'll miss some, Okay. So I think this is the end of the class, and see you next